Okay, let's continue. So the question you may ask is, it's cool that we have the feature importance, but how are they calculated? And the long story short, that is the mean decrease in the impurity. Okay, so let me come back to my drawing board and remember when we are doing a split. So we are gonna split. We will split a node with n samples into two children. So with n1 and n2 samples. And on the root we have the Gini, and then on the children one we have the child one, we have the Gini one, and child two we have Gini two. So if we want to have the weighted children's Gini, and then it should be n1 divided by n, and then Gini, Gini 1, and plus n2 divided by n, and Gini 2. Okay, so that is the weighted Gini of the children, and then the drop will be the Gini of the parent and minus the weighted Gini of the children. Okay, so that is the drop, and this is what we are measuring. So if we have a good feature, and then from a parent to two children, and then we will have a big drop of the Gini. So if this feature has a lot of splits, and then for all the splits the sum of the drop or the mean of the drop is really a lot, and this means this feature has to be a good feature. Okay, so you may ask, this is this the best way to get the feature importance? And probably there are better ways. So usually people will say this is the first way to get the feature importance if you're running the random forest. However, there are better ways grounded by theoretical proofs, and they are more robust than the random forest feature importance. However, the people who designed the random forest argue that this random forest feature importance is also a reliable measure of the feature importance. So you may ask, in the real world, is that my work? Is that the scientist's work in finding the feature importance? The answer is not always. When you have a data set and when you're collaborating with the domain person, I would ask for the domain expert's idea on, hey, what's the most important feature if you have to guess? And don't be afraid to ask this question, because building the model and cleaning the data and making the visualization, that's definitely your work. However, for the domain person, if you are collaborating with the domain person, and that domain person should provide you enough background of this project and give you enough domain knowledge to kick this project started. And then for the feature importance, it's kind of somewhere here. So my suggestion is, don't just take it as your job. Go ahead and ask for help from the domain person first, and then if the domain person says, okay, I'm not quite sure, please go ahead and find the feature importance by yourself. And then you do that part of the work. Okay, so the next part is an exercise. So remember, what we had at first was, we are taking the months as a numerical feature. We did a mapping. January maps to 1, February maps to 2. And the reason I'm doing that is, I'm arguing January is the first month and January plus 1 is February, right? It may not be that important. So for example, if we all know we are living in a touristy town in the summer, right? So this means for the June, July, August, September, those are the busiest months. So in this case, are we gonna treat June, July, August, and September as 6, 7, 8, and 9? Well, it doesn't seem to be quite reasonable to me, because those four features are those four distinct values are gonna show there is a better to a higher number of the tourists. However, well, are we gonna say 5 plus 1 is 6? So May increased by 1 is June. Does that really matter? Or I would just create a column, say June, yes or no, July, yes or no. So which one is better? Well, it really depends on the problem we are trying to solve. So since I'm not sure which way is the correct way, I'm going to do something different this time. I'm going to ask you to create the one hot encoder for the month too. So month December, month February, month January. So I'm treating all the months like as distinct values, as independent features to each other. Okay, so February is just one column, January is another column. Well, and then we won't be able to tell January plus 1 is February. So let's massage the data this way. So after we make the data this way, we have to train and split again, and then we make the random forest, train that, and make the prediction. So eventually we want to have the feature importance again. So after we have the feature importance, and then that is not the feature importance for a single column, because now we will have 11 columns, I believe, because there are a total of 12 months and we are going to drop one anyhow. Okay, so the next part is we want to put the add together the sum of the feature importance of the months, of all the different months, and then let's take a look on the total. Okay, so go ahead and pause the video here and then do the coding by yourself. Okay. Okay, so well, I'm gonna show you my answer here. So I load the data again, and well, I just add the months to the categorical feature, and then I do one hot encoder with all those categorical features. So after that, I do the train test split again, build the random forest, and train the random forest and make the and after training I didn't even make the prediction, and I just make the data frame of the feature importance. Okay, so this is the feature importance I got. So the first month, the first important month is March, and followed by June, and followed by August and July. So okay, so June, July, August, they are the important months. Okay, so after that, I did a iteration. So for this iteration, as long as the index of a line starts with the month and underscore, and I'm gonna add that to the total importance of the month, and after that I just print that out. So adding all the importance of the months together, we have a 0.10. So 0.10 is roughly here. So I would say, well, adding all the importance of the months, and it seems that all the months are still kind of meaningful. Okay, so which month is the most important feature? And I believe that's March. Is that correct? Yep. So March is the most important feature. So does that mean there are more successful sales in that month? The answer is no. Well, it could be either way. It could be there are a lot of successful sales in March, or it could be just the opposite, because in the March, well, the sales are the least successful. Okay, so anyhow, March is a big feature. So the next thing, well, after we have done the one hot encoder, and we will find that there are a lot of features, and really a lot. And this is kind of annoying, because if you check the least important features, that they are less than 0.1%. Okay, and then if you check the most important feature, that is 27%. So clearly there are some quite important features, and there are some really unimportant features, or you can say they are throwaway features. Okay, so my next question is, how about we just keep the two features, the most important two features, duration and age. So after that, we create another another training set, but only with those two most important features. And then go ahead and do another random forest model, and remember only with two most important features, and then try to get the accuracy score. And after that, try different values. Say, well, try the top 3 features, top 4 features, top 5 features, and then get the accuracy scores for each of them, and eventually you want to make a plot. Okay, so if you make this part of this kind of the plot, and you may get a good idea on if we increase more features from the important ones to the less important ones, and then how many features do we really need to build a decent model. Okay, so go ahead and work on the coding here, and I will show you the answers in the next video.